Consider the expansion of 1 plus 3x to the power of n where n is a positive integer. The coefficient of x cubed is 6 times the coefficient of x squared. Find the value of n. So to start, we need to find the coefficient of x cubed and the coefficient of x squared. So for x cubed, first of all, we know that we have n choose something, 1 to some power, 3x to some power. Given that it's cubed, this has to be 3, which means this is going to be n minus 3, and this is going to be 3. Using the formula for n choose r, this is n factorial over 3 factorial n minus 3 factorial. This is just 1, and this is going to be 27x cubed. Now for the coefficient of x squared, we do a very similar process. It's going to be n choose something, 1 to a power, 3x to some power. To get x squared, this one needs to be 2, so this is 2, and this is n minus 2. Using the formula again, this is n factorial over 2 factorial n minus 2 factorial. This is 1, and this is 9x squared. Now what we're told in the question is that the coefficient of x cubed is 6 times the coefficient of x squared. So the coefficient of x cubed, first of all, is going to be, multiplying through here, 27 n factorial over 3 factorial n minus 3 factorial. And we're told that that is equal to 6 times the coefficient here, which is 9n factorial over 2 factorial n minus 2 factorial. Now we've reached an equation. If this happened to be a calculator paper, we could solve it in our calculator at this stage, but this is probably a non-calculator question. So let's carry on and work this out. How would we simplify this? We're going to use the rules of factorials here to simplify these two things. So this is 27n times n minus 1 times n minus 2 times n minus 3 factorial over 3 times 2 n minus 3 factorial. On this side we have 6 times 9, and then n factorial is going to be n minus 1 times n minus 2 factorial over 2 times n minus 2 factorial. Now we can cancel the n minus 3 factorial there and there, the n minus 2 factorial there and there. The 3 is going to cancel with the 27 to give us 9. And we can leave it like that for now. We get 9n n minus 1 n minus 2 over 2 is equal to 6 times 9n n minus 1 over 2. Given they're both over 2, we can get rid of those. Given they're both times by 9, we can get rid of those. Now we might want to say, given they're both times n, we could get rid of those n's as well, divide through by n. And the problem with that is we're going to lose solutions if we do that. So we're not going to do that. We're going to keep the n's there because that's not a constant term. So now we're left with n minus 1, n minus 2 equals n times n minus 1. Now I could certainly expand this and then try and solve it that way, but actually, sorry, not n, it's 6n there because I still have that 6. Right, it's actually easier, or quicker anyway, to do something slightly different here. Let's bring all this onto this side. And then what I'm going to do is I'm going to factorize out the n minus 1 that is in both of these terms. So I get n minus 1. And then what am I left with? Here I'm left with n minus 2. And here I'm just left with minus 6. And that's all equal to 0. Which means I have n minus 1, n minus 8 is equal to 0. Which means n is either equal to 0, 1, or 8. But thinking of the original problem, because it was the power 1 plus 3x to the power of n, if n was 0, then this wouldn't have an x cubed term. If n was 1, it also wouldn't have an x cubed term. So it can't be 0 or 1. Essentially what it's saying in those cases is that this coefficient is 0 and this coefficient is 0, and then this is technically true, but that's not a valid expansion really. So actually the answer is the 1 value of 8.